AP Chemistry, Chapter 8, Chemical Bonding, the size of ions. Last chapter, we reviewed looking at the trend of atomic size. And for neutral elements, as we proceed down a column, we know we get larger and why we get larger. When we proceed across the period, we get smaller, and we understand now why we get smaller. Well, what happens to a neutral element when it gains or loses electrons? Sodium. Sodium is the largest of its period. We know it commonly forms the +1 cation. So, when an electron is lost, what happens to its size? Sodium, when it becomes a +1, has one more proton remaining in its nucleus compared to its remaining electrons. That enables the nucleus to pull even more strongly on the remaining electrons. Sodium neutral is always larger than its associated cation. Cations are always smaller in size than their neutral counterparts. Whenever we form anions, let's take fluorine for example. Fluorine is very small because it's the end of its row. Whenever it forms fluoride and we gain an electron, anions are always larger than their neutral counterparts. And why is that so? Electrons are pathetic in their size. So it's not that we're adding more as far as size that then would lead to a greater volume. Whenever we are adding electrons, the ground state configuration has done its best to minimize the repulsion between electrons. We are adding another, and electron repulsion is heightened. To minimize the repulsion that is caused by adding an extra electron, the entire electron cloud expands to accommodate and lower the energy that is raised when we add an electron. So to minimize this repulsion, anions are always larger. Let's take oxygen. Oxygen neutral. As we add one electron to avoid extra repulsion, it gets larger. To add the second electron to reach the octet, it gets even larger. The same as we form multiple charge of cations. Magnesium is such a size. As we take away one electron, it decreases in size. Take away another, it even decreases further. So as we're comparing ions with their neutral counterparts, we need to understand how things change size because of that. Remember, I'd given this handout to us in Chapter 7. Well, the back of it we can now explain and focus upon. So, to give us definitely the trend of size, we can see numbers. Now, these radii are given in angstroms. An angstrom is 1 × 10⁻⁻10th meter. It was really created, and it usually has that little knot over it, to really reflect atomic size. We can see how our anions get larger. We can see oxygen is already larger than fluorine. When it becomes a -2, it even becomes larger in size versus the -1. And we can see just the trend and the behavior looking here. And this is going to have a lot of impact on lattice energy that we will talk about with ionic bonding. So it is important to understand what happens to our size whenever we create ions.